because this is the square,
Yeah.
and then plus 1.
There you go.
Makes sense. Okay.
So, we're going to be working with algebra tiles. This is for Algebra 1 at a 9th grade level. We're talking about completing a square, and we're learning how to move from vertex form. You guys all know what vertex form looks like?
Yeah.
Great. So, we all know about standard form. That's my warm-up, is going over standard form versus vertex form versus factored form. So what you're going to do is we first go through the first one together, and I'm actually just going to view the first one, and this is what the first one looks like. The standard form was x squared minus 6x plus 10. And we completed that square to be x minus 3 squared plus 1. That is the completed square for this specific one. And now I'm going to have you guys work through the rest of them. And the whole idea behind this is I want to see if you can notice a pattern between going from standard form to vertex form and try to develop an algorithm for completing the square. Yes. So you're going to you can do them together, you can do that one. Think about what you notice in the relationship between the vertex form. Maybe writing the vertex form would have been good for the first one. Yeah, you got it. To go from that form to, and see if you can develop an algorithm for it. And that's the activity here.
So, wait, so vertex and not
Standard form to vertex form.
Really?
Not factored. Go from here to here. So you start with standard form.
Plus 2 squared. Minus 5.
Good, I'm doing it mathematically here.
You're trying to factor it though.
Yeah.
These can't be factored.
Are you sure?
Yep.
I think so as well.
What do you get?
I'm just doing this for
So x plus 2 squared minus 5.
Yeah.
So if you were to expand that, would it work?
Yeah, x squared plus 2x minus 5.
To go back. See if it works.
Fact.
See if you can go from that form to the other form and see if it works.
I want to build things. I want to throw eggs at people.
Like to teach the world to sing?
Yeah, that does not work.
So what are you going to need to complete that square? Because this is that patterns you're looking for.
Negative x's, I don't know.
5 positive.
X squared plus 2x. Minus 5.
Yeah, but then you have a positive 5 and a negative 4.
It has to be plus 5. Why does it have to be plus 5?
It's minus 5.
But if it was plus 5, it would make sense.
When we had the minus one here, you put plus
Or no, if it was.
But that was
Never
when
mind,
we
never
had the thing that
mind.
it was all here, we needed a positive. And then to get rid of that, we needed a negative.
I know, then why is this a
If it
positive?
was a positive, you added
So
it.
this would be minus.
We added a negative one. So we have a negative minus 5. But it doesn't work when it's like if you want to expand it.
Well,
You
because
don't.
the plus 4 is right here. Well, the minus 2 is right here. Is that what you're saying?
But this is so this isn't factored correctly.
J's are up by 2.
Plus 2 minus 2. X plus 2.
You can just square it.
Oh, that's not square.
Yeah, it's not a square.
Yes.
Okay, try the last one.
You telling us that that one wasn't right?
No, I got it written on mine correctly, but
Which one are we doing? Problem 3?
Minus 2x squared.
just some feedback. I like this part, but this part seems a little rough to read. It just seems.
Oh,
like
this,
it's
yeah,
heavy.
for kids?
Yeah.
Yeah, no, definitely.
But I like this part.
What do you think, Allie? Plenty? Yeah.
So what's the first thing you notice that's going to be a problem here?
There are two X's.
Negative 2x.
How do you make a square with two X's?
I don't know.
X2x squared, Colin.
You gotta do it like this.
Those are
With the
negative.
algebra tiles?
What about like?
Just
I don't
flip
know.
over.
What about like this?
Red.
Oh, thank you.
And then.
That's a rectangle.
You're
What's the? Well, you're not going to be able to make it with two. What's an easier? What's a way to do it? What would make it easier?
Divide by 2.
with
If you use
extra
another two, but what's
more.
even easier?
Divide by
Oh.
2.
Just do it with one.
So divided
So
by
pull
two.
the two out
Divide
of
by
the
two.
original equation.
Emily's head.
Whoa!
Can I say it again?
That's the A value.
Can I say it again?
What did you say, Pat?
Divide by 2.
The last one?
So what'd you get?
Come on, last one. Like this, senor. I don't know.
So how are you going to make that into a square?
It is a square.
Take away
You need to take away these two, right?
Uh huh.
So it's going to be parentheses 2 and negative 2. Oh, I'm at 15 minutes.
Are you?
I'm at 7 minutes.
It feels like forever, but it's not. Maybe we should do a braid race.
I'd say this is definitely doing math
Yeah.
because it hurts.
Well, and to be fair, we learned the procedure before, so this makes this even harder.
Yeah, you're
For
right.
them, if they haven't learned the procedure first.
Well, and he's having us look for
How
patterns,
many is
and
this
I like that.
algebra
So is it that?
Someone take it away from me.
But you're
I
If
right.
you
always
expand
just
that
use a
out,
lot
how
of-
many
Find the
Oh,
square.
squares do you get?
Why? Oh,
I would just
too many.
Google how to find a square.
If I had a whiteboard, I would
Can we
have.
clap for him? I don't think we clap.
Too many.
We clapped for Emily.
So what'd you get for the next one? What'd you get as your equation for
Mental
the
class.
vertex form for the last one? You pulled out. You pulled out 2.
Yeah, we pulled out.
Pull out two.
And then what do you have in your? What do you have in? You have negative x. One.
Negative x squared and 2x.
So negative x. So what's this length?
X plus one. Plus one.
Negative x plus 1 squared.
Plus one.
And then you have
Minus 2.
Minus 2 because you have 2 x. So that would be your completed square on the
So
last.
okay, wait. On that first one, were we wrong? We had
this
one.
makes
We had
sense
one
because I
extra.
never
We
really
added
had-
one. This time we have 2 extra. So
Oh
we
no, we would
subtracted
add 2.
2.
We would add 2.
Still got it.
Plus two.
Okay, plus 2.
But technically, all this would be in. So it'd be. So now, if you combine it, how many would you actually have to add to complete the square? Why?
Because we did half 6.
You pulled 2 out. So what's the relationship between what numbers? Looking at the ones you've written down, what numbers do you notice are similar? H value versus A value, B value, or C value. That's the patterns you're supposed to be looking for. So what about the A value? And you have this equation: y equals A x minus H plus K. Where's the A value come from? Look at,
This formula.
where's the A value come from? Look at the last equation you have.
It's negative
Coefficient.
Coefficient of the x.
negative 1.
Coefficient would be
Squared.
x squared.
Yeah.
So
Negative
it's
1.
the same A value. A stays the same. What about the H value?
H comes from the
And the easiest one to see this one is the first one.
Same.
From the
Yeah, it's the same.
It's the same. Remember, this is the first one.
It's
Yeah, it's the same.
X value. The B, whatever.
It's half the B value.
minus 2x
Half the B value.
a squared
What about the last value?
Okay.
Your
The
K
plus- the
value.
plus one.
How do you go from the K value, the B value, to the K value? Think about completing the square.
I remember now.
Opposite.
I remember from Google.
Take
Reciprocal.
half
Inverse.
value.
Take half the b-value, then what do you do?
Take that last number and divide it by half the b-value.
You take half the b-value, then what do you do with that b-value? Take half of it, then what do you do?
Add to the other side.
Half the b-value is 3. Half the b-value is 3. How do we get from 3 to 10?
Square it.
Square it.
Square it, and then what do we have to do?
Add one.
Plus what?
One.
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 There's your completing the square.
It's been so long.